All right, so on this first one, we're actually going to do the whole part. Like, we're going to finish it up, do the graph and everything. The one on the back, we need to learn something new today, and then we'll come back and do all of it. All right, so yesterday we learned about horizontal asymptotes. So F is asking for the horizontal asymptotes. So yesterday on the worksheet on the back, I tried to separate like into two columns, one where you use the original form and one where you use factored form, so you can kind of get it straight in your head. But for horizontal asymptotes, do I want to use the original or do I want to use the factored form? Original, because we're going to compare the degrees of the numerator and denominator. What do you guys notice about those degrees? They're the same. So what's the horizontal asymptote going to be? Numerator divided by denominator, which is going to be 2. So F is y equals 2, and then I'm going to go back to the graph. I'm going to graph a horizontal line where y is equal to 2. All right, now G asked about slant asymptotes, which is what we're learning today. And I'm going to go ahead and give you a little sneak peek that if there is a horizontal asymptote, there is not going to be a slant asymptote. So we're just going to go ahead and say none. And we'll learn about the reasons why in just a second. All right, and then the limit notation for the end behavior, we did learn that yesterday. So the end behavior is going to be the limit when x approaches infinity and when x approaches negative infinity of f of x. So we just said our horizontal asymptote was y equals 2. So what should both of these be? 2. So horizontal asymptote is what the graph gets closer and closer to at the very, very ends of the graph. And so the end behavior is the horizontal asymptote if there is a horizontal asymptote. All right, so we can do this whole graph. Now on the left side of the vertical asymptote, we actually don't have any points out there, but it's okay. We can use other things we wrote to kind of figure out what's going to happen. So on part E, we wrote that on the left side of negative 3, the graph is going to be going towards positive infinity. So what I'm going to do is on the left side of my vertical asymptote, I'm going to start kind of at close to the top, and then I'm just going to curve. Not supposed to be jagged. I'm just going to curve through and then approach the horizontal asymptote. So that's one branch of my graph. Now the other side is really nice because I already have 2 points in a hole that I know my branch is going to go towards. But I also wrote on E that on the right side of the negative 3 is going to be going towards negative infinity. So I'm going to start at the bottom on the right side. I'm going to go to my hole. I'm not going to go through it. I'm just going to like stop and then pick back up on the other side of the hole, go through the points, and then approach the horizontal asymptote. All right, so we did a whole graph. What questions do you guys have about the graph? I know this is the first time you guys are doing rational graphs. Okay. All right. So we're going to learn the last thing, slant asymptotes. All right, so a slant asymptote is like a regular asymptote, except it's going to be a slanted line. So instead of vertical or horizontal, it's going to be slanted. So it's still going to be a line that the graph is going to approach, but like I said, it's going to be slanted. So if the numerator degree is exactly one more than the degree of the denominator, then the rational function has a slant asymptote. So if the numerator's degree is more than the denominator's degree, can there be a horizontal asymptote if the numerator dominates? There's not going to be a horizontal. So sometimes when there's not a horizontal, there's a slant asymptote, but the numerator has to be exactly one more than the denominator. And then to find the slant asymptote, you're going to divide the numerator by the denominator, and you're going to ignore the remainder. So the coefficient, which is going to end up being your slope, and the constant, which is going to be your y-intercept, are the only part that matters. The remainder you just kind of ignore. And the reason why is because if you guys remember, you always will like put the remainder, we'll say it's 2, over the divisor. And then at the very, very ends of the graph, that is going towards infinity. So it ends up kind of being like 2 divided by infinity. So it just doesn't matter in the grand scheme of the graph. All right, so let's do some. So some of this is just like yesterday, and then we're going to kind of add in a slant asymptote here and there. So on this example, we're going to find the horizontal asymptote or the slant asymptote. They can't have both, one or the other, and then give the end behavior. So looking at A, does A have a horizontal asymptote? Let's see. No. So if the numerator degree is larger than the denominator, there's no horizontal asymptote. So if that is none, then we need to check to see if there's a slant asymptote. And so when you do that checking, you see if the numerator's degree is exactly one more than the denominator. What do y'all think? Yes. So there's a slant asymptote. So we're going to divide the numerator by the denominator. Can I do synthetic division in this case? Yes. So as long as that denominator is something just like x plus a number or x minus a number, I would recommend that you guys do synthetic division. You can always do long division, but obviously it's way longer. What number should I put in the box? 1. So it's going to be the opposite of whatever's down there. And then I'm going to bring over my coefficients and constant of the dividend. And then we are just going to bring down that first coefficient and then multiply and add. Now we do get a remainder of 5. We don't need it, so I didn't even write it. You can mark out that too. We only need the 2 and the 3. All right, so anytime I divide using synthetic division, whatever the power is on the dividend, it should go down by 1. And this should always, in this case, if it's a slant asymptote, it should be the equation of a line, a slanted line. Y equals 2x plus 3. All right, so on this, we could use like those polynomial rules to figure out our end behavior, or you can just kind of visualize what this graph looks like. It may have been a long time since you have graphed a line, maybe since Algebra 1, I don't know. But what would the y-intercept of this line be? 3. So what you would do is you go to 3 on the y-axis, and then the slope is 2. So you would go up 2 over 1. So this is pretty much what the graph is going to look like. And so the graph of the rational function is going to follow that same pattern as you go out. So what is the limit as x approaches as x approaches positive infinity of f of x. If it's going to look like that line, positive infinity, and then the other one is negative since it's pointing down on that side. All right. Any questions on that? All right, let's look at B. Does B have a horizontal asymptote? Yes. And what is it? Yeah. So since the degrees are the same, we're going to do leading coefficient divided by leading coefficient, which is just going to be 3. And so if there is a horizontal, you don't even need to think about the slant. You can just automatically say none if there's not going to be one. All right, what do you guys think about those two limits? They're both 3s because that's what a horizontal asymptote means. As you go out, you're going to get closer and closer to 3. All right, one more. Let's look at C. Does C have a horizontal? No, because the numerator is dominating. So we just need to look closer at those degrees. Does it have a slant? Yes, because the numerator is 1 more than the denominator. Can I do synthetic division? No. It's okay. We can do long division. And we don't even have to do the whole problem. We just need to do it until we have like the equation of a line at the top. All right, so you ask yourself, what do you multiply x squared by to get x cubed? And that's just going to be x. And then distribute that x. Okay. And then be real careful that you subtract both of these. So you change both those signs. And you're going to get negative 5x squared. And then bring down the minus 6x. Okay. And then you ask yourself, what do you multiply x squared by to get negative 5x squared? And that's going to be negative 5. And then you can stop. Because that's the equation of the slant asymptote, y equals x minus 5. So it really, if there is a slant asymptote and you're doing long division, there should only really be 2 steps or 2 numbers at the top. All right, so hopefully you can kind of picture what this graph looks like. Y-intercept of negative 5, slope of 1. So on the right side, we're going to be going towards infinity, and on the left side, we're going to be going towards negative. All right, so on the back is everything that we've done this week. The only thing that's not on here is finding where a function is greater than 0, and it's okay. We'll practice that again before the test. All right, so let's see if we can do it all. What's the first thing we need to do? Factor. Good. All right, so what number is not in the domain? Negative 2. Do I need to box any of these factors? No. So you only box if they're exactly the same, and they are not. All right, so then we're going to do the x-intercepts and y-intercept. Okay, so anything that's not boxed up in the numerator is going to be an x-intercept. So I do want the factored version for that. What version do I want for the y-intercepts? Original or factored? Original. We could do both, but original is going to be way easier. So all we have to do is kind of cover up or ignore anything that has an x. And then what does that reduce to? -3. So 0, -3. All right, so I'm going to go over and graph all those things, my x-intercepts and my y-intercepts.
Wait, how'd you get the y-intercept again?
Okay, you're going to put 0 in for the x's in the original. So I just kind of cover them up. All right. Is this graph going to have a hole? No. So if you haven't boxed anything up because they are like factors, sorry, I meant to say none, there's not going to be a hole. All right. Is this graph going to have a vertical asymptote? Yes, that's the -2. So anytime something is not in the domain on a rational function, it's either a hole or a vertical asymptote. So to graph this vertical asymptote, I'm just going to do a dashed line when x is -2. All right. And then to use this limit notation to describe the behavior at the asymptote, that's where we do this table of values. And we're going to plug in something on the left side of -2 and something on the right side of -2. So a little bit smaller, the -2 is going to be -2.1, and a little bit bigger is going to be -1.9. And then you just set up these little parentheses matching up with however many factors you have in the problem. And then you just plug in and see if you get a positive or a negative. Right. And anytime there is an even number of negatives when you're multiplying and dividing, it's a positive. All right, and then just clicking them into the factored form. When there's an odd number, it's a negative. And because this is a vertical asymptote, I know that positive means that on the left side, the graph is going to be going towards positive infinity. And then negative means on the right side, the graph is going to be going towards negative infinity. And we'll have to wait till we're done with it to be able to actually use that in the problem, but we will. All right, so then F is asking for horizontal asymptotes. Do I want to look at factor or do I want to look at original? Original. And what do you notice about the degrees? The numerator is dominated, the numerator is bigger, so there is not a horizontal asymptote, which means there possibly could be a slant. Is there a slant? Yes. Can I do synthetic division? Yes. So let's do that. So I'm going to do the opposite of the denominator on the box. So that means that my slant asymptote is y equals x minus 1. All right, so we're going to graph this line that has a y-intercept of -1 and a slope of 1. So I'm going to go up one, right one, up one, right one, and I'm just going to make a dashed slanted line out of that slope. Okay, and then I'll also go down one, right one. I'm sorry, down one, left one. Okay, so as I move out to the far left and right, the graphs should be getting closer and closer to those. Okay. Oh, we have one more thing to do, and then we'll do our graph. And when we're doing the limit notation of the end behavior, just know that it's going to do whatever this line is doing at the ends. So because as we go to the right is pointing upward, that's going to be positive infinity on the right, negative infinity on the left. All right, and then we're just going to do what it says. So it says that on the left side of this vertical asymptote, it should be up at positive infinity. So that's what I'll do. I'll start at the top on the left side, and then I'm going to curve. It's going to be kind of steep, but I'm going to curve through that intercept and then go towards my slant asymptote. Now that's a little wobbly, but it's fine. All right, and then we also said back at E that on the right side of the vertical asymptote, I'm going to be at negative infinity. So I'm going to start at the bottom and then just curve through those points and then get closer and closer to my slant. That's it. So what questions do you guys have? We're going to finish that last example that we've been working on all week. We'll get one more practice with slant asymptotes and one more practice doing the whole graph. All right, so we need to do F. So we're deciding if there is a horizontal asymptote. I'm going to look at the unfactored version. Is there a horizontal? No. Is there a slant? Yes. Can I do synthetic division? Yes. So let's do all that stuff. So none. Synthetic. So I got that my slant asymptote was y equals x plus 2. So I am going to go to my y-intercept of 2 and then do a slope of 1. And then I can just use that line to describe the end behavior on H. And then I can draw my branches. All right. I'm going to extend my vertical asymptote up a little bit more because that y-intercept is way high. And that should be kind of evidence that you're going to start up there at the top. But if you look at E, we did say that on the left side of 1, it is going to be up at infinity. And we'll curve through those points and then go towards the slant. All right, and then on the right side, we said on part E is going to be negative, so we're going to start at the bottom. And we'll have 1 point, and that's okay. Okay, right. So on your worksheet, the back is doing practicing all the things, and I don't know if you guys are leaving early. I feel like you might be leaving slightly early.